The displacement of a particle is given by x is root 3 sine pi t minus cos pi t. Find an expression for x in the form r sine pi t minus alpha. So if we think about r sine pi t minus alpha, we can write that as r sine pi t cos alpha minus cos pi t sine alpha. And then expanding, we can write that as r cos alpha sine pi t minus r sine alpha cos pi t. Comparing coefficients, we can see that r cos alpha must be equal to root 3 and that r sine alpha is equal to 1. R is then going to be the square root of 1 squared plus 3 squared. Sorry, that's root 3 squared. So that's root of 1 plus 3, root 4 gives us 2. And then dividing here, the r's will cancel. Sine alpha over cos alpha is tan alpha, so tan alpha is 1 over root 3. And that tells me that alpha is equal to pi by 6 radians, 30 degrees, but obviously we're working in radians here. So we can write this as 2 sine pi t take away pi by 6. Hence, or otherwise, find the amplitude, phase shift and period of the motion. I'm just going to rewrite this slightly as 2 sine pi t take away 1/6, like so. Now this gives me the amplitude, so the amplitude is going to be 2. Now the period for the standard sine is 2 pi. This pi in here tells us that we have a horizontal dilation, scale factor 1 over pi. So that's going to give me a period of 2. Now the reason I took this out is the phase shift can be read directly, and the phase shift is going to be 1/6 of a radian, and it's going to be, because of the negative here, to the right. The displacement of another particle is given by x is root 3 sine pi t minus cos pi t minus 3. Find the maximum displacement. So we know that we could write that as 2 sine pi t minus pi by 6 take away 3. So the maximum value of this, the maximum value of sine we know is 1, multiply that by 2 gives us 2, so x max is going to be 2 take away 3 is equal to -1.